Yeah.
yesterday I got the link in the drive, but
Mm-hmm.
one file is PDF. That one is okay. The other file is video, no?
Yeah, yeah.
हाँ, लेकिन वो ओपन नहीं कर सकता।
Why? I tested that. मैंने पहले उसको टेस्ट किया फिर मैंने सेंड किए.
हाँ, फिर
Um, even I tested in incognito mode so that
oh,
anyone can open that.
then I'll check
Uh,
again, sir.
yeah, please check again, and I will check it again and
Okay,
send
sir.
you the link which is going to work.
Okay, okay, sir.
So, well, for today we are starting lecture 2,
Yes.
and previously we were discussing OSI model
Yes.
and the layers it contains and the functionality of each layer, and
Yes.
most importantly the focus was on the transport layer,
Yes.
which is managed by operating system. It is a backbone layer and it performs segmentation, windowing, and TCP UDP mechanism, and multiplexing, demultiplexing. These are the core functions. There are other functions which happens on the transport layer as well, like flow
Yes.
control and these kind of things. Okay. So
Okay, sir.
transport layer is a kind of a layer which is very busy and which performs a lot of tasks, and all the tasks or most of the tasks are performed by operating system. So operating
Okay.
system is responsible for how the data is passing through from this layer.
Yes.
Okay, so
Okay.
basically this is why it is open system. Means
Oh,
that application, presentation, session layer, these three layers, the developer is responsible, and
oh,
developer has to make sure that each layer's functionality is uh, performed and secured. But when the data comes to transport layer, it's not in the hand of developers or the vendor or company which is developing that app or software.
mm,
Okay, they are not
okay.
responsible. Now it
Mm,
all comes to operating system. Now
yes.
operating system needs to handle the data. So
Okay.
whichever operating system it is Windows or Mac OS or Android or whatever, it
Mm,
is now responsible for managing that data.
yes.
Uh, uh, well, let's continue to the network layer.
Okay.
Network layer has two major tasks. I just wrote 2 points here: best path selection, which is called routing, and logical addressing, which is IP. Usually we say IP address,
Mm,
but there are IPX, a protocol which was used earlier, and Apple Talk and TCP IP is the standard which we are using right now. Okay, so
okay.
multiple addressing methods were there, but now it is only TCP/IP, which is a standard.
Okay.
Uh, we are not going to discuss much more here because the network layer is the approx 30 to 40% part of our course. So
Okay.
we will be discussing this layer thoroughly. Means
Okay.
when you talk about the network administrator or the cybersecurity administrator or something like that, they usually have to perform most of the work on the network layer.
Yes.
So we will be discussing network layer in detail in multiple sessions. We are going to discuss what network layer does, how does routing happens, how does logical addressing work, and everything. So don't worry about this that there are only 2 points and we are getting ahead. It is going to be discussed in very detail.
Okay.
Another layer is data link layer after the network layer. The data link layer is for the switching purpose. It's LAN switching or WAN switching, either it is LAN or WAN, and it is responsible for physical addressing, like the MAC address. And
Okay.
MAC address has three other names: the
Mm,
physical address, hardware address, and burn-in address. So whatever word you see, it means that it is all about the physical address, which is MAC address.
yeah.
Okay, so
Okay.
sometimes you will see that the address is hardware address, so it means hardware address is also a MAC address. The BIA is also MAC address, and physical address is MAC address. Usually, I discuss MAC address a little bit more because it's a small discussion, and we know usually don't have to discuss further about it because it is a hardware address, so we can't manipulate it.
Okay.
The MAC address is consists of 48 bits and managed by IEEE.
Yeah.
Now let's start the story of MAC address.
Okay.
MAC address is a hardware address, and uh, we need to make sure that every device in the world has a unique MAC address.
Yeah.
No devices, no multiple devices can have same MAC address.
Mm.
Okay, because if they have same MAC address, there will be a clash kind of
Mm.
things.
Mm.
So how does the IEEE ensure that every device got a unique MAC address? So
Mm.
it is not possible to assign a MAC address for every device.
Yes.
So what they does, they divided this 48 bits into two parts of 24 bits.
Okay.
The first 24 bits are usually known as vendor ID.
Right.
Okay, and the
Okay.
second 24 bits are serial number.
Okay.
For example, um, let me see what is my MAC address of my laptop.
Mm.
So I type the command ipconfig/all. Obviously, you are not seeing this because
Yeah.
it's on another screen,
Ah.
but here is the MAC address. And I just copied it. We can use MAC address lookup,
Yeah.
and there are multiple websites,
Mm.
MAC address vendor lookup. And when I paste my MAC address here,
Mm.
basically these are the MAC addresses I previously searched in
Mm.
my previous classes.
Ah.
So what it tells me that this is starting 24
Mm.
bits.
Ah.
And how does I know that they are 24 bits?
24 bits.
Yeah, because it is written in hexadecimal format.
Ah. Ah.
And each hexadecimal character contains 4
Eight.
bits.
Ah, 4 bits.
Okay, so
Okay.
4 plus 4 plus 4 plus 4 plus 4 plus 4, it will be 24 in the end.
24.
6 fours are 24.
Yes.
Okay, so now it is telling me that this device is registered to Toshiba. So Toshiba is the vendor who has this MAC address.
Mm.
Okay, so
Okay.
and yeah, this is the name I was trying to remember.
Mm.
OUI.
Oh.
Okay, it is
Ah.
called OUI. What is the full
Okay.
form of OUI? I have to search it. I forget this.
The first
OUI.
part is called OUI.
OUI. Yeah, the vendor ID is also known as OUI.
I have another
OUI.
doubt. I don't know whether it
Yeah.
is stupid doubt or not.
No
Actually,
problem. Just ask.
the operating system is like it is made up of chips and all, no? So
Yeah.
this MAC address is it is a logical address or
No, it's not a logical address. It's
it
a
is written
physical address.
somewhere.
Yeah, it is written on the hardware IC chip, which is
Mm.
in the LAN card.
Ah, okay.
Okay,
But
and one device can have multiple MAC addresses. Means in my laptop there is a LAN card which is connected to
um,
the wired network, and there is another LAN card which is connected to wireless network, and there
um,
is another communication mechanism, the Bluetooth. Okay,
Bluetooth, yes.
yeah. So every communication card has its own MAC address.
Okay.
Okay,
Communication card means this is it
every
network
communication
card?
card. No, no, not only the network card.
Ah,
Means basically what is a network?
a
What was the
network
definition?
connection of
No,
no
not just a connection. Communication.
communication is
Okay, communication between multiple devices.
device.
So every device which can communicate with another device via any medium or any method. Any method mean if it is connected through a LAN network or a wireless LAN network or a Bluetooth network or a hotspot kind of network. Okay, and there are
Okay.
new technologies like LoRaWAN and something Zigbee.
Ah,
I hope you ever heard about these kind of names.
yes,
So
some of
Zigbee and LoRaWAN. Okay, basically uh, uh, they are more familiar with the IoT kind of things,
ah,
Internet of Things.
ah,
So
Zigbee I have heard.
yeah, Zigbee and LoRaWAN, they both.
Yeah.
LoRaWAN has they both have other uh, uh, capabilities as well, but
Ah,
most of the time they are discussed when we are going when we discussing IoT communication. Okay,
okay.
so whatever the communication, I mean that. Okay, every device that needs to communicate must have a physical address.
Mm,
Okay,
okay.
so
Okay.
if you check your, let me bring it here.
Yeah.
So let me see. Here I have multiple, basically my laptop has an Ethernet adapter. Okay, wide
Ah,
network, for wide network. This is
ah,
the MAC address.
okay.
Then these Ethernet adapters are basically virtual box
Ah,
adapters. So they have physical addresses as well, which
okay.
is MAC address.
Market.
Then my wireless LAN adapter.
Ah,
So wireless LAN adapter also has a
another address.
physical address.
Ah,
Then my wireless LAN adapter Wi-Fi.
ah,
There are multiple. I don't know why. It is also have a MAC address. Means
mm,
it if it is a physical or it is a virtual address.
ah,
Even Bluetooth, the
yeah.
Bluetooth device also has a MAC address,
Oh,
which is physical address. So
okay.
each
Bluetooth
device,
means our headset and all.
Bluetooth means?
Bluetooth device means this headset, earphones, everything.
Yeah, exactly. Headset, earbuds,
Oh,
whatever
everything
your
has their
device
own
is.
physical address.
Yeah,
Ah, okay.
all the devices have their own physical address, which is
Ah,
also known as MAC address or
ah,
hardware address or BIA, burn-in address.
burning address. Ah, okay, that's why
Okay.
it is called burning address.
Yeah, because it is burned in the chip.
Ah,
Okay.
okay.
So
Yeah.
vendor
Okay.
ID, or what was the other name?
OUI.
OUI, which
Yeah.
is the full form of Organizational Unique Identifier.
Ah,
Okay.
okay.
So now my notes are getting updated
Mm,
whenever I am teaching.
mm,
Let me, yeah, now it looks good. Okay. Oh, now, what is the number? The 24 bits.
ah,
So in 24 bits, we can have approx 16.7 million possibilities.
yes.
Okay.
Ah,
This is the wrong, but how can I have? Um, yeah, this is
ah,
right.
mm,
Okay, it's approx, not is equal
but,
to.
ah,
Okay, so 2.20, sorry, 2 to the power 24 is 16.7
mm,
million vendor IDs, which can be generated by IEEE.
okay.
Okay, so what
Okay.
IEEE give an ID to Toshiba. Now what Toshiba can do, they can generate 16.7 million serial numbers.
Ah, ah, okay.
So
Okay.
for this 16.7
Ah,
million devices,
ah,
they can use a single unique vendor ID, unique identifier
ah,
or MAC address, vendor ID. Okay.
okay.
Now, for example, they manufactured 16.7 million devices. Now they need
Ah,
more. What they will do? They will contact IEEE and it will
ah,
provide another vendor ID
another. Ah, ah,
because it has 16.7 million vendor
family.
IDs,
Ah,
which is not a small number.
ah, yes.
Means we don't have millions of vendors in the world.
Ah,
Okay,
yes.
we
Yeah.
vendors are limited
Limited, yes.
and they need limited if they need more numbers, they can get
Uh,
the vendor ID. And
and in
usually,
uh,
yeah, yeah,
when Toshiba, for every devices of Toshiba, it is unique. I mean, it is same.
exactly.
Whatever
Me,
they make, the vendor ID is same for Toshiba.
yeah, exactly.
Either
But
phone,
until
laptop.
they reach this number,
Until they, okay, okay,
okay,
sir.
then they will going to get another vendor ID.
Ah,
So that's
okay.
how it is managed by IEEE, and that's how all the devices are unique. So for Toshiba, it
Mm.
is different, but
Ah,
if I search for the Dell, it will be
mm.
different.
Ah,
Okay,
okay,
I
okay,
hope this makes sense.
yes.
Okay, so this is the story of MAC address, and this is
Mm.
how MAC addresses are managed throughout the world, and they are
Mm.
unique.
Okay, sir.
There is a very, very rare chance that there are two MAC addresses collide. It's a
Ah,
very rare chance.
okay, yes.
Okay,
Got it, sir. Yes.
how can two MAC addresses collide? I said very rare chance.
Mm,
How can that
by
chance happen?
mistake.
No, not by mistake. Basically, what vendors does
Mm.
uh, when they ask for IEEE to assign them an identifier or something like that, they
Mm.
need to pay for that because
Ah,
IEEE is also managing and they have infrastructure. They need to bear their expenses.
ah,
So what they do, they uh, provide a license or something like that, or they ask for some money.
ah,
So what vendors does that they uh, utilize their old vendor IDs. Means sometime means for example they took a vendor ID in 80s or in
ah,
90s.
ah,
Now it's 2024 5. So
ah,
what they does that they use the 90s vendor ID again because they assume that now the that 90s devices from the 90s are
ah,
not going to work anymore
ah, ah.
right now.
Yeah.
Okay,
Ah, okay. Ah, ah.
so that's why
Like all
they
the phones and all.
yeah
Ah,
like old phones IMEI numbers.
ah, ah.
Sometimes they use it again. Okay.
Again, okay.
Uh, and there is another major difference we are going to discuss about network layer and data link layer.
Mm.
The basic differences we discussed that it is about routing, it is about switching,
Ah,
it is
okay.
about logical address, it is about physical address.
Yeah.
Another major difference between network layer and data link layer is that
Mm.
network layer functionality is global.
Okay.
Global means that whatever my logical address is, I will
Ah,
be represented by that logical address
ah.
throughout the internet.
Internet, yes.
But
Ah,
the data link layer or physical address,
ah.
the data link layer or the physical addressing, its impact is local.
Local, yes. In
My
land.
MAC address, yeah, my MAC address is not going to get outside of my network.
Okay.
The packet or the data I am sending,
Yeah.
it doesn't carry the MAC address of my laptop over the internet.
Ah,
So we will going to understand that how does that happen in
yeah.
detail. But
Okay.
that's a basic difference between them. So these
Mm.
two layers are totally different from each other and they have their own tasks and purposes.
Yes.
Now we came to the physical layer, which is the last layer we should need to discuss.
Mm.
Managing medium controllers, interfaces, or physical ports. It's all about the physical things which
Ah,
can be accessible.
yeah.
And the medium can, if the wide medium it is, we have multiple cable types like copper cables and fiber optic cables. And
Okay.
if it's a wireless medium, we have radio frequencies.
Ah,
Okay.
yeah. Okay.
So
Okay.
physical layer is not a thing which we need to discuss
Okay.
much, uh, 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 which we need to discuss a lot.
Ah,
Now here is the OSI model summary.
okay.
What this summary tell us? The first thing is the reference. I
Yes.
told you the importance of
Yeah.
reference.
Yes.
Okay. So
Mm.
there are multiple, there are references for each layer, by which reference the layer is called when we
Yes.
discuss technically.
Yes.
So layer 3 is network layer, layer 4 is transport layer, and here the data name.
Data.
On
Data.
the top three layers, data is just a data.
Ah.
But when it comes to transport layer, it is known as segment.
Segment.
So
Ah.
if someone say that I think the segment is not delivering properly, it
Ah.
means that it is a issue of transport layer or layer
Ah.
4, or it is something which is concerned with operating system.
Ah. Yes.
Similarly, the word packet is entitled for network layer.
Ah. Network. Yes. Ah.
So whenever in technical discussion you heard the word packet, it
Ah.
means it is network layer discussion
Ah.
or layer 3. Also,
There.
for the reference, it is also called as layer 3.
Yes.
Okay. And this is the usually managed by router. Router is the device who is responsible to deliver packets properly.
Ah.
So you will going to troubleshoot the router
Ah.
or the device or the other options which are related to the router or routing.
Okay.
Now we have another name which is frame.
Ah.
Frame is
Right.
strictly connected with data link layer,
Interlink.
the layer 2.
Okay.
So these three layers have these different names for the data. So
Ah.
when these names occurred, it means that this is means to be connected with a different layer.
Okay.
So segment is connected with layer 4,
Ah.
packet is layer 3, frame is layer 2, and layer 4 is transport, layer 3 is network, layer 2 is data link.
Interlink.
So for the network administrator, uh, these three layers, reference numbers, their data names, their management devices, and their functions,
Ah.
they are most important. They
Okay.
must remember at least this portion of the OSI model.
Ah.
This portion is the core portion which is related to the network administrator or any person who is working with networks.
Okay.
Now we have in the end layer, obviously layer 1, which is physical layer, and there our data is transmitted in bits,
It's.
and it is usually managed by hub, but not necessarily that every time hub is there,
Ah.
because we can directly send those bits on the medium.
Okay.
Okay, so any questions in this summary? Because this is the overall summary of OSI model where all the previous things we wrote, I guess, are here.
Okay. Sir, we are learning more about this router, switch, everything later, no?
Obviously,
Yeah.
yeah,
Okay.
these are the 70 to 80% course. The
Ah.
70
Okay.
to 80% course is about router switches and
Ah.
how routing and switching works, and
Yes.
what are the protocols, what are the methods,
Ah.
everything about routing and switching.
Yes.
Basically, a few years back, the CCNA we are learning that is named as CCNA routing and switching.
Ah.
Now Cisco combined many things here, and
Ah.
they called it CCNA 200-301 version, which is part of everything.
Ah.
Previously, Cisco have CCNA routing and switching as a different
Mm.
uh, certification, CCNA
Ah.
security as a different certification, CCNA voice over IP as a different certification. But
Ah.
now they combined everything, and
Everything.
they called it CCNA, just
Ah.
CCNA
Okay.
200-301.
Ah.
Okay.
Okay, sir.
Have you joined NetAcad account?
Uh, sorry, sir. No.
No. Let me tell you something which is
Ah.
very helpful, which might be very helpful for you.
Okay.
NetAcad.com. This website,
Netacad. Okay. Netacad.com.
this website is Cisco Networking Academy website, the
Um,
official Cisco Network Academy website.
Oh.
And if here you go to explore, just create an account. There are multiple subject areas and courses are here. Many of us are just free. Means which course is mentioned as self-paced. It means you don't need any instructor or any academy to join this course. You can just start this course by joining this platform.
Okay, so net
Okay.
yard. Okay.
NetAcad, and there are and there are areas, introduction to cybersecurity. Obviously, it will be helpful for you. The ethical hacker, it will be helpful for you. And there is another benefit, which is this, the badge.
Oh.
Okay, so you can earn the badge by completing this course, and obviously you can learn much more with this course. There are multiple labs, and it is self-paced, and obviously it will boost your resume.
Yeah.
So how does badges work? This is how.
Okay,
There is
sir.
a website, Credly.
Exactly.
So whenever you complete a course which contains the badge from Cisco or any other, um, where is my profile? Here it is. No, not the profile. The dashboard. How can I see my dashboard profile? There, this is how your badges are shown. Okay, so you can share your Credly profile to someone, or your Credly profile link in your resume. From here, that these badges can be verified.
Oh, this is your badges, no?
Yeah, these are my badges. There are
CCN.
3 pages.
Okay.
Mm. I have multiple. Basically, I used to be addicted to the certifications, and I have multiple certifications. I am a Cisco trainer. I am a Microsoft certified trainer. I am a Huawei trainer, certified trainer. So I am, because I am in this field, I know how to um, clear the certifications and earn these badges. But I usually tell my students that they should be going after these badges as well. They they impact a lot in your resume. They have a very big impact, because these badges are not from any local institutions or some things. They are from Cisco, or even you can earn from Microsoft or Huawei. Huawei also provides a lot of free courses. Okay, so I will tell you about the Microsoft and Huawei later. But for the starter, I must say that you must join this NetAcad and start learning from there. You can start learning cybersecurity, the networking basics. There are networking courses which are self-paced. So you can start learning these courses, and they are going to give you badges, and obviously the learning material which is very well uh, crafted by the Cisco. Okay, so I will encourage you to uh, uh, give some time to your personal
Yes, sir. I'll do it
growth.
parallelly so that if I have any confusion, then I can ask you.
Yeah, exactly. This is the purpose as well. If you start any networking course, the basic networking course, and you see that we learn something which is contradicting, or you are not getting that point, so we can discuss it in the session.
Okay, sir.
Okay, so let's move ahead. I guess this summary is enough.
Yes, sir. Clear.
Okay, now there is a term which is known as encapsulation. Okay,
Encapsulation. Yes.
encapsulation is a generalized term, is a vast term. Usually with OSI model, it is related like that every layer encapsulate its information with the data.
Yeah, yes.
Okay, so
Okay.
when, for example, I wrote an email.
Uh,
So when the application, which is an email application like Outlook or Gmail, uh, what they does that they will attach the information of the email protocol
uh,
which is being used, like
okay.
SMTP,
Yeah.
Simple Mail Transfer Protocol, like
Uh,
POP, which
uh,
is also a email protocol. Okay,
yeah,
so
okay.
they are going to attach that information, and that is encapsulated. A
With the data.
layer, a layer, in a layer, what I say, मतलब कि वो एक layer जो है ना उसके ऊपर चढ़ा दी एक तरह से ना,
Uh,
ठीक. Then we have presentation layer which also attaches in its information over it.
uh,
Then the layer 5 is attached the information, then layer 4, then
uh,
layer 3, layer 2, finally it comes to the layer 1. So
okay.
from a side, from the sender,
Uh,
every layer encapsulate something, its information on the
uh,
data, and when this data reach to the other side,
uh,
every layer decapsulate its information one by one, and in
uh,
the end user got the actual data.
uh,
After every layer decapsulate or remove its information.
okay.
Okay, so
Mm,
for example, that because in three layers we are calling it just data, but
uh,
on transport layer, the transport layer attach the TCP header or the
yeah.
UDP header, which
Uh,
contains the segment number
uh,
or port number.
yeah.
Remember the port numbers
Yes.
we discussed.
Yes, sir. Yesterday. Yes.
Okay, so
Yeah.
these information is connected here, and now it become a segment.
Yeah.
Okay,
Okay.
then the data comes to network layer. It encapsulate and attach the information IP header,
We had done.
which
Yes.
is the logical address, IP address, or
Uh,
the next path criteria, that how where this packet is going to be transferred, and this is called packet.
uh,
Okay, we can't call this data a segment
uh,
which data has contained IP information.
okay.
Okay, so it is
Okay.
segment.
Segments. Yes.
Then another layer connected, sorry, encapsulated its data, MAC address or LLC. LLC is a WAN kind of MAC address. It is also a hardware address.
Uh,
Okay,
okay.
and FCS, the checking bits for uh, making sure that the data which is received is as it is in condition as it was sent. Okay,
Same.
for
English.
checking parities type things.
Parity. Yes.
Yeah.
We have
So
studied.
data link layer attached is its information, and
Uh,
it is called as, what's the name when the data is on data link layer?
Packet. Frame. Frame.
Frame.
Yeah. Is it frame?
Okay, it is
Frame.
frame.
Yes.
So segment, packet, frame.
Frame.
Layer
Yeah.
4, layer 3, layer 2.
Yeah.
This must be remembered because
Uh,
throughout the course, I will not be using these names.
uh,
I will be using I will be using the
segment.
layer reference
Uh,
or the name packet segment kind of thing. Okay.
okay. Okay, sir.
Now they finally we have physical and it is on the network media. So one
Uh,
side it is encapsulated, the other side it is decapsulated.
decapsulate. Yes.
So encapsulation and decapsulation is, and this happens a lot with the data.
Uh,
Even a single layer can have multiple encapsulations. We
uh,
will see that on the network layer, there will be not a single encapsulation, but multiple encapsulation as per the requirement.
oh, okay.
Now we have another model, which is TCP/IP model.
Yeah.
So in 1984, the OSI model was developed, and it has 7 layers. But in 1989,
Uh,
another model came, which is known as TCP/IP model.
uh,
OSI model and TCP/IP model, these both models have a basic difference, is that we called OSI model a logical model. Okay, means it's logical. There is
Okay.
nothing present physically about OSI model. It's
Okay.
just a logical model that logically the data should be transformed through these layers or encapsulated into these layers. But
Okay.
TCP/IP model is a physical kind of model which is implemented through their TCP/IP protocol suite.
Okay.
Okay,
Protocol suite.
OSI model doesn't have any protocols attached to this,
Ah.
but TCP/IP protocols are a complete set of suite which follow the TCP/IP model.
Okay, sir.
This makes sense, or is there any confusion?
Protocol, but we have studied protocols in OSI model too.
Exactly. We have studied protocols in OSI as well.
Ah.
That every layer the application layer will attach the information of the protocol.
Ah.
Okay, but it is logical. Means if it attaches, uh, it is going to work. If it doesn't attach, it is going to work.
Ah.
Means a vendor should do this. Open system. Okay, a vendor should do this. A vendor should follow these layers whenever
Oh.
it is sending the data.
Ah.
But vendors can violate this as well.
Ah. Ah. This
Okay,
is
means
just an architecture. Ah.
if I am a vendor, I have my own hardware like Apple.
Oh.
I have my own operating system. I have my own network communication mechanism.
Ah.
Okay, so
Ah.
I can violate OSI model and I can do whatever I want to do with the data.
Ah.
I do no longer need to follow
Ah.
the OSI model because it is logical.
Ah.
You never follow logical things. Sometimes you change them.
Okay.
Okay, so you can change. But if you are following the TCP/IP protocol suite,
Ah.
which is standards, which are standard protocols,
Ah.
then you are following the TCP/IP model.
Oh. Ah.
Okay, but
Okay.
in real world,
Ah.
you will never heard about TCP/IP model.
Oh.
Means people discussing about the layers, they they are not going to discuss about the TCP/IP model layers.
Oh.
They are always referring the OSI model
That's
layer.
another.
It is the standard, it is the norm.
Oh, okay.
Means in our discussions, we are
Ah.
going to say it is layer 1, it is layer 2, it is layer 3, it is layer 4. We are
Ah.
not going to say that layer 3 is transport layer now. It is not
Ah.
changed.
Ah. Yes.
Okay. Means
Okay.
someone in the interview asked about to you explain layer 3. So you
Ah.
are not going to ask him of which model, OSI or TCP/IP.
Ah.
Okay. It is
Okay.
it is a norm of the industry that
Ah.
if they are talking about layer 3, it is
Ah.
OSI model layer 3.
Oh.
OSI model is the reference model.
Ah. Okay. Ah.
Okay. TCP/IP model is not a reference model.
Oh.
Okay. But
Okay.
what it does that it combines the functionality of the application on a single layer.
Ah.
It combines the functionality of these two layers because data link layer also contains the physical address.
Ah.
It is also contains the hardware LAN card.
Ah.
Okay. So they
Yeah.
combine these.
Okay.
But transport layer is as it is
Right.
on the means it is not touched. The network layer is converted its name to internet layer.
Mhm.
Okay, but this is not the industry standard for reference.
Ah.
Okay, keep that
Which is,
remember.
sir, is TCP/IP model is a tailored model which is made out of this OSI. Is it?
Exactly, and it is a Taylor model which
Mm.
provide a protocol suite,
Good.
standard protocol suites.
Okay.
Means that HTTP protocol is now a protocol which contains all three
Ah.
information about all three layers information in its program or in its a stored procedure.
Ah.
Okay,
Okay.
so
Yeah.
HTTP is the protocol which is responsible for all these functionalities
Okay.
of these layers. Similarly, SMTP, it is a standard protocol. Telnet, FTP, DNS, RIP, SNMP, XYZ. Okay, there are thousands of protocols
Protocols,
which
yeah.
are standard and
Okay.
used by the developers for ease of developing. Means
Okay.
they use HTTP for browsing and it is a standard.
Okay. Sir, I
And
have one
there,
other doubt.
yeah.
Actually, sir, yesterday we have studied that example WhatsApp, they have their own protocol, no?
Mm-hmm. No,
Then,
let me clear it.
uh,
I never said that WhatsApp has a complete new protocol of their own. Okay,
uh,
let
uh,
me clear it. I
uh,
guess it was a confusion and it's a very valid confusion.
uh,
I said that they created their own mechanism,
uh,
okay, uh,
okay.
from for the uh, message encryption or message sending or
Uh,
message delivering kind of purposes.
uh,
But it is possible that they combined that mechanism with the standard as well.
okay. They may be using OSI model, no? Because
Ex they no. They
TCP.
OSI model is a model which is the core of communication. Whenever a communication is happening, it is using OSI model. Okay, let it be clear. Means
Yes.
OSI model is not kind of thing which is obsolete
Yeah.
because it is logical.
Yeah.
Logical things cannot be obsolete.
Yeah.
Okay,
Yes. Okay.
so the all the communication happening, they are happening using the OSI model
Uh,
logically.
okay.
But maybe WhatsApp using FTP along with their own protocol in their app.
Uh, uh,
Means if I send you a file
uh,
and if you are downloading that PDF file through WhatsApp,
uh,
so on the background it could be FTP or
yeah.
any other file transfer protocol which is standard. There are multiple file transfer standard protocols for file transferring.
Okay.
Okay, so
Okay.
WhatsApp is and even another thing. Let me clear another thing.
Mm,
FTP is a standard,
yeah.
and
Then. Uh,
everything FTP does, how it does, what is its algorithm.
uh,
Okay, it is
okay.
all available because it is
Ah,
open source.
open source. Yeah.
So what anyone can do, it can
Uh,
tailor it.
uh.
Okay,
Yeah.
it
Yeah.
can mold it according to its need.
Okay.
Okay,
Okay.
so whenever when I can tailor the FTP
Uh,
protocol according to my needs.
uh,
Okay,
yeah.
so
I get it.
WhatsApp can do this, Facebook can do this.
Okay.
So there are the standard protocols, there are
Uh,
the tailored version of a standard protocols, there
okay.
are protocol standard protocols with
Uh,
uh, customized protocols working in the
okay.
same app.
Uh,
So it is not hard-coded kind of thing that if
uh,
you are using this protocol, then you can't use another protocol in your app.
uh,
Okay. An
okay.
application can use multiple protocols. Either they are standard or they are tailored or they are customized, whatever, however they are made.
Okay.
Clear?
Clear, sir. And
Okay. Yeah, yeah.
TCP/IP, this protocol suite, they contain many number of standard protocols, and
Exactly.
yeah, and
There
all
are
those
thousands
who
of protocols.
okay, those who use this model, this TCP/IP, they should select from that standards only, or
Basically, if I am developing any app and I
uh,
select any standard protocol, so what I
uh,
am doing, I am following the TCP IP model.
uh, then we can tailor it.
Yeah,
Okay.
yeah. That is programming and development kind of thing to
Uh,
tailor that
yeah.
because it can take a lot of
Uh,
programming knowledge because the SMTP protocol means there is a code written behind it. There is an algorithm.
Okay.
which decided that how the message is going to delivered. Uh,
Oh,
if it is not delivered, what would happen, how things are going to work.
okay.
Okay,
Yes. Yeah.
so this is all defined in these protocols in
Yes.
hard-coded coding,
Okay, sir.
the program. Okay, so the developers need to be well aware of how to mold them.
Yeah.
Must be a highly uh, intellectual kind of developers.
Oh,
Okay,
okay, sir.
okay. So there are these uh, protocols. We usually work with the Ethernet. The tokening is for wireless, sorry, WAN.
Oh,
ATM is for WAN. Frame
oh,
relay is for WAN, and Ethernet is used for LAN network.
learn. Yeah.
So basically, this layer is about LAN or WAN network. If we
Yeah.
see that data link layer is responsible for deciding either the communication is on the LAN or it is on the WAN.
Well, yeah.
We are going to discuss about LAN and WAN
Yes. Okay, sir.
right now or later. I don't think so. Uh, well, there is not a big discussion about LAN and WAN. What
Oh,
is the difference between LAN and WAN? Can you tell me?
yeah. LAN means it is a local area network
Yeah,
within a
yeah.
building.
In a building or in a small area, no, small geographical area.
Yeah.
And WAN is,
Area is wide.
yeah, wide area network and large geographical area. It covers large geographical area.
Yeah.
This definition is kind of right. Okay.
Uh,
But the core definition
uh,
or the core difference between LAN and WAN is uh, the management authority. Okay.
oh,
I meant that, for example, if we are referring LAN, it
uh,
means the LAN is managed by uh, an organization
uh,
uh, which is connecting its devices
uh,
on its own network, and they are
yeah.
managing everything.
Yes.
Okay.
Okay.
For example, a bank.
Uh,
Okay. So the bank inside its building or its inside its premises
uh,
manage all the devices
uh,
is called its LAN because it is managed by the
the
bank.
bank.
They are
Yeah.
responsible if anything happens. Okay.
Okay. Either
They
wired or wireless.
either wired or wireless. Okay.
Okay. Okay.
When is when there is a third party or service provider involved.
Uh,
Okay.
okay. Okay.
So I usually give example of university.
Uh,
We have here a big university, Karachi University,
uh,
which is expanded on kilometers.
uh,
Okay, but
okay.
if the Karachi University management
Uh,
managing all the connectivity of their departments, which
uh,
are kilometers apart from
apart.
each other,
Uh,
it's a long distance.
yeah.
Geographically, it's a long distance,
Long. Yes.
2 kilometers or 3 kilometers or even 5 kilometers.
Uh,
Okay, but if it is managed by university itself,
uh,
it's a LAN.
uh,
Okay, it's a
okay.
LAN.
Yeah.
But if, I mean, I am using the internet in my house.
Yeah.
So inside the devices which are connected, like my phone and laptop, all the things which are connected to router are
Uh,
LAN. But
that I was
as
going to.
but
It is a land,
as
small.
yeah, it is a
Uh,
LAN. Okay, but it is a small LAN. Geographical area is very small.
uh,
Okay, a house
yeah.
means the geographical area can either be very large or
Uh,
very small. It is a
uh,
LAN until it is managed by
I.
the organization or the
Uh,
user itself who is connecting those devices, who
uh,
is responsible for the connectivity. But
yes.
when the service provider comes, it
Uh,
is now a WAN.
uh,
Okay. For
okay.
example, in Karachi University,
Uh,
there is a service provider
uh,
which is responsible to make sure connectivity between departments.
Ah,
Okay, so
okay.
each department has its LAN, and when
Ah,
it's connected to another department through the service provider, it is
ah,
WAN.
okay. Yes.
Okay, so
Okay.
LAN or WAN has the difference when the service provider came.
Mm.
Until the service provider is not involved, it is LAN.
Okay.
It doesn't mean that it should be a very small area or it can't be expanded to large area. You can expand it to large area, it is a LAN.
Okay. Yes.
Okay, so LAN or WAN difference is about service provider.
Ah,
Now
sir,
yeah,
sir, in LAN, how usually we connect without any service provider?
any here it comes. Now
Ah,
we are going to learn about the LAN.
okay. Okay.
Okay, so basic
Yeah.
networking concepts and definitions. A few basic
Yeah.
networking concepts and definitions which need to
Ah,
be remember. There
yeah.
are words like simplex, half duplex, and full duplex.
Full duplex. Yeah.
Simplex is one-way communication, half duplex is two-way communication,
Mm.
but one at a time. And
Ah,
the Mashhur Zamana example is walkie-talkie.
yeah. Yeah.
Okay, and
Yeah.
then we have full duplex. Full
Full.
duplex that both are communication at same time.
Okay.
Okay. Now, how do you know that it is a half duplex communication or a full duplex communication? Simplex doesn't exist in networks.
Okay.
Okay, there is no
Ah,
network which works on the simplex
duplex.
mode of communication.
Yeah.
Every network needs to send or receive the data. Either it
Ah,
is half duplex or full duplex.
full
Okay,
duplex.
two-way communication is the core of network communication.
So TV and radio is one way, simplex one.
Yeah, they are simplex,
So
exactly.
they don't belong to network.
No, they don't belong to network. The network
That's
we are talking
another
about.
kind of communication.
Yeah.
Ah,
Okay. So network communication is whenever we are having a two-way communication.
ah,
Okay.
okay.
So what happens when you need to uh, think or when you need to finalize that if it is a half duplex communication or it
Ah,
is a full duplex communication, how you decide that? You decide that on the presence of medium.
ah,
Okay, the medium
okay.
is used. In
Ah,
half duplex communication, a single medium is used for sending
ah,
and receiving the data.
okay.
Okay, but in
Okay.
full duplex mode, we use two mediums to
Ah,
send or receive the data.
did.
Let me search it for the very first time.
Ah,
Half duplex and full duplex network. Pins. I am searching this for the very first time.
ah,
Okay.
mm,
So this is similar. RJ45. RJ45. Have you seen network connectors before? This is a silly question. Everyone sees them. Connector pins. Oh, hello.
hello, sir.
Yeah, I asked that have you seen the network
Ah, yes.
cables? Okay.
Connectors, yes.
Yeah. So, how does they work? For example, this here comes. Here comes it is. Oh, it is
Mm,
RJ50, not RJ45.
mm,
Well, let keep it simple. So
mm,
usually we have um, a connector with 8 wires, and we
mm,
say that 4 pairs:
mm,
orange, green, blue, and brown.
yes.
2 pairs are uh, used to send or receive data.
Mm,
If the 2 pairs are used to send or receive data, it is full duplex.
Full duplex. Ah,
Okay, one
okay.
is for sending and one is for
Sending,
receiving.
receiving. Ah,
But what I can do,
ah.
I can bring it here.
Is
So
this
you can see
VNI?
the shortcut ncpa.cpl. Okay, it
Mm,
is an important shortcut
mm,
for a person who works with networks.
mm,
What it does,
ah,
nothing big. It just open this window.
ah,
Okay, network setting window.
ah, ah,
Now, what I can do on my
ah,
wide network, I
ah,
go to properties,
ah,
configure,
ah,
advanced,
ah.
and there is this option speed and duplex.
Oh,
And I can change my communication to half duplex.
oh,
Okay, when
ah,
I change this setting and I
ah,
change this to half duplex,
ah.
100 Mbps half duplex,
Duplex.
what is going to happen?
One receive, one port,
One pair,
one pair
okay,
disables.
one pair disable, and only one pair is going to be used for sending or receiving data.
Receiving. Okay.
Okay,
It will
so
be slower.
this, yeah, it will be slower. It can have the collision issues
Ah,
because on the same medium I'm sending data and on the
ah,
same medium I'm receiving. So if the
ah,
device on the other hand send me data at the same time,
ah,
the data can be collide
okay.
like a one-way road.
Ah, ah,
If the traffic is on the one-way road and there is only one car which can pass through,
ah,
and from the opposite two cars came, they are going to
ah,
collide unless
yeah,
unless one stops
yeah,
and reverse it back if its ego doesn't hurt.
ah,
Usually ego comes first.
yes.
Okay, so what happens here? Half
Ah,
duplex communication is when
one way.
I want to use one pair
Hmm.
of my network port.
Port, yes.
Okay, and
Okay.
it still exists
Ah,
in the network devices.
oh,
Okay, there
ah,
are network devices which works on half duplex exist. Even the latest devices, each device,
ah,
even the newest switch,
ah,
the newest laptop, every device which can connect to the wide network. Okay, it is all
oh,
about wide network. You can change this on the wide network, not on the
ah,
Wi-Fi network.
ah,
Okay, this is
okay.
something related to the wide network because we are talking about the pairs
Ah,
physically connected. Okay,
yes.
so half duplex communication is the mode which is available and
Ah,
can be used. And there is auto negotiation. So what will happen if I am connected to a device
ah,
or which is uh, in set on the mode of half duplex? So what
ah,
my laptop is going to do? It is
uh,
going to change its
disable.
mode to half duplex.
Half duplex, yes.
Okay, so half
Okay.
duplex exists. This is the
Ah,
proof.
yes.
Now, what is going to happen
Ah,
when half duplex communication taking place?
ah,
Collision.
yes.
Okay, so
Okay.
the shared medium caused half duplex communication, half duplex
Ah,
caused collision.
pollution,
Okay,
yes.
so data is collided when we
Ah,
have half duplex communication, and
ah,
uh, uh, when we have half duplication, it's because we have the shared medium.
yes.
Okay, so they are interconnected to each other.
Ah,
This arrow should be two-sided arrow.
yes. Ah,
Well, let it remain the same because it is making sense somehow.
ah,
Now there is another definition. Okay, there are modes of communication. There's another word used is casting, means
casting.
propagation.
Hmm.
Okay, it is written in the Urdu as phailao, means
Correct.
where the data is going to propagate or
Ah,
how. Uh, okay, so there are unicast, multicast, and broadcast. Three types of
cast.
casting.
Ah,
Unicast is one-to-one,
one to one.
means if I am going to send data to a person direct to a person, and no one other is going to receive that data, it is unicast, like a
Yes.
WhatsApp message.
Oh,
Okay, then there is multicast, one to many, like a WhatsApp
one to
group
many.
message,
Yeah.
and there is broadcast, one to all, like a
One to
WhatsApp
one.
status.
Yeah. Ah.
Okay, Uh,
Okay.
I set a WhatsApp status and everyone is
Ah.
going
But
to see.
yes.
Okay, so
Ah.
these terms are very
Ah.
important to keep in mind: unicast,
Mm.
multicast, and broadcast, and
Broadcast.
we are going to use this term.
Ah. Okay.
Now there is another definition or another word which is very common in the IT field. It is domain.
Domain. Yes.
Okay, domain is a generalized word, but when we talk in networks,
Ah.
the domain is known as logical group of devices.
Ah. Logical
Okay,
group of.
logical group of devices means, for example,
Ah.
uh, there is a university which has multiple computer labs.
Ah.
So what they does that they obviously all the labs are connected physically to each other,
Ah.
and they must be using the same internet, because they can't afford us different network or different internet connectivity for all the labs.
Yeah.
So what they does that they can logically group each lab and call and name it, for example, lab 1 devices or
Ah.
lab 2 devices or lab 3 devices. So that will be a logical group.
Ah.
Physically they can be connected to same network, but
Ah.
logically they are going to divide. We will work on that. Okay, we will see
Okay.
how this is going to happen.
Ah. Sir,
Huge, yeah.
we are using this for network configuration.
Yeah, these definitions are going to, or these words are going to be used when we are going to configure network.
Okay. Sir. Okay.
Okay, so when we will be configuring a network,
Ah.
we are going to create domains. We are going to discuss about these domains. We are
Ah.
going to discuss about these terms: unicast,
Ah.
multicast, broadcast.
Broadcast. Okay.
That in this network the data is broadcast, or in this network the data is multicast, or this kind of data is multicast, or
Ah.
this kind of data is broadcast.
Broadcast. Ah.
Okay,
Yes.
so we are going
Okay.
to discuss that. We
Okay.
are going to use these terms.
Ah.
That's why the better understanding of these terms should be in our mind before
Ah.
we start to use these terms.
Yes.
So broadcast domain and collision domain, these two
Yes.
domains which are which used in the networks.
Okay.
Broadcast domain is the group of devices which can receive each other's broadcast messages. Okay, so
Okay.
if I send a broadcast message, all the devices who can receive my broadcast message are counted in my domain.
Mm.
Okay, what could be the real world example of this? Like the TV channel,
Ah. Ah.
they call themselves as broadcasters.
Broadcast. Yeah.
Okay, but
Yeah.
is it essential that if a channel is broadcasting, so everyone in the country is watching the same channel?
No.
No.
Ah.
Why? Because they not everyone in their broadcast domain. The
Ah.
only users in their broadcast domain who tune that channel.
Ah. Ah. Yes.
Okay, so
Yes.
broadcast means that one to all, but it
Ah.
doesn't mean that one to all mean that everyone is going
Ah.
to be on the same domain. It
Ah.
is only going to be on the same domain if it is configured
Ah.
in that
Ah.
domain.
Yes. I got
Okay,
it.
so if
Okay.
the user tune the frequency
Ah.
of the
Ah.
broadcaster, then it is going to be on the same domain, and then it is going to receive the
Ah.
transmission.
Yes.
Okay, similarly the collision domain,
Yeah.
group of devices
Okay.
where data can be collided.
Ah.
Okay, so
Okay.
means there are, this is the example,
Ah.
these two devices are in the same domain, in the same
Ah.
collision domain,
Okay.
because their data can be collided with each other.
Ah.
But these two devices are not in the same collision domain.
Ah. Ah. Yes.
Okay. Why?
Okay.
Because their data can't be collided.
Collided.
So I hope these terms makes sense. We are going to
Yes.
use them, and
Ah,
we are going to describe them when we are going to use them.
yes.
Then we have LAN network.
Yes.
So the LAN network is going to be clear. There are topologies. Topology is arrangement of devices.
Yes.
So if someone asks you what is topology, just uh, throw these words: arrangement of devices.
Device.
How you arrange a device, it is called a topology. There
Topology.
are standard topologies,
Ah,
there are non-standard topologies, means I can connected my devices upon my will.
ah,
It is my network, means because LAN network is a network which is managed by me.
yeah.
There is no one interfering. So I can
Ah,
arrange my devices on when as ever however I like.
yeah.
So the standard topologies are bus topology, which is a
Topology.
very outdated topology.
Ah,
Cable was coaxial cable. Coaxial
ah.
cable is
Coaxial cable.
the old cable, the black color
Ah,
cable we used to connect the TV,
ah.
if you remember.
Yes, yes.
Okay.
That round shape.
Yeah, yeah.
Ah,
A single wire is going through and
ah,
there is a jar over it. That
ah.
is coaxial cable.
Yeah.
So coaxial cable was used, that was a shared medium architecture as you see here.
Ah,
Everyone is connected.
I
What
see.
is there? We use a T type of connector
Ah,
to expand the network. It is
yes.
always half duplex because
Ah,
there is shared medium,
yes.
and because it is half duplex and everyone has to access the shared medium,
Ah,
there is access method. So
okay.
whenever a half duplex communication occurs,
Ah,
this standard access method
ah,
arrives.
okay.
Sysma CD.
Okay.
Carrier
Interesting.
sense multiple
Multiple.
access collision detection.
Okay.
So this is the carrier.
Ah,
What every PC does, it
ah,
sense
ah.
before sending the data.
Okay.
Okay, before
Ah,
multiple access,
ah,
everyone try to sense that if the medium is free or not.
ah,
So what this PC does, it send a sense bit and
ah,
check if the medium is free. If
ah,
medium is free, then it is going to send its data.
ah,
And when it is sending data, if
ah,
anyone else sense, it will sense that it is busy, so it will pause
ah,
until it send another sense bit after a while
ah,
and check if now the medium is free, and
ah.
then it is going to send its data.
Okay.
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 But it could happen that this PC or this PC send the sense bit at the same time.
Mm.
Then what is going to happen?
Collision.
No, the collision will occur after that.
Ah,
They both got a sense reply response that
ah.
medium is free,
Three. Ah,
and they both think that medium is free. So
yeah.
now they both try to send their
Mm.
data
Ah,
at the same time.
ah,
That's where collision occurs.
ah,
And when the collision detected,
ah,
what happens? They uh, start a tandem timer uh, on their PC to
ah,
again send before sending the sense bit, and again
mm,
sense, and then again send the data which was collided and
ah,
lost.
ah.
How do they know that our data is collided? How
Ah,
can they know?
um, the data won't be reaching the destination.
No, that's not how. Basically, the data which comes on the medium is
Mm.
now in the in the what should I say, in the type of bits, or it is now current flowing.
Flowing. Yeah.
Okay, the high
Ah,
and lower bits are different voltage levels.
ah,
High bit is refer usually as 5 volts and the low is as 2 volt or something like that. It is about the mechanism they are using. Okay, means
Yeah.
that high can be 15 and the low can be 5. So because there are random uh, electricity produced, so when it is sending something, means it is sending some electrical signals. When it is sending something, it is sending some electrical signals, and those electrical signals collided.
Ah,
Okay, the
ah,
electricity got
cancel.
cancelled or something like that, and
Ah,
it is going to receive the uh, electrical signal.
ah,
Means it's a sender, so
yeah.
it should never receiving any signals.
Ah,
So that's why they know that that data is collided. So it is something related to your BTech.
yeah.
I hope it is going to make sense to you more than me.
Mm,
Okay.
okay.
So let's go ahead. Difficult to troubleshoot, obviously,
Ah,
because if there are 20 PCs in an office and a
ah,
single cable is uh, going through each of them, so
yeah.
the issue is going to difficult to be
Yes.
troubleshooted.
Ah,
Broadcast. Everything is broadcast here.
ah,
It is not possible that this PC send data to this PC and no other PC is receiving that.
yes.
It is
Ah,
impossible.
impossible.
Okay. So that's why we say that broadcast domain is one in this topology,
Ah, ah, ah.
and collision domain is one.
But
Every
sir,
device
broadcast supported means?
means that this topology supports broadcast. If a broadcast message is sent,
Ah,
everyone is going to receive
ah,
that.
receive. Yeah.
Okay, and it only support broadcast. It doesn't support unicast.
Ah, ah,
We can send a message to a single PC, and
ah.
we cannot make sure that other PC are not receiving that message. They are going to
Oh,
receive ultimately, because in the end it is electrical signal. So
ah,
everyone is going to receive that.
receive. Oh,
They are not going to process it
ah,
because
oh,
that's
ah,
not
ah.
belong to them, but they are going to
Oh,
receive.
receive it. Ah, ah, ah.
So
Okay.
that's why
So
it is
we
only
cannot
brought.
configure it like it, others are not receiving it.
Yeah, it is not
Ah,
possible here. It's
ah,
impossible because it's a shared medium.
ah, ah. Okay, okay.
Okay,
Yes.
means it's
Good.
kind of pipeline going through
Ah,
an apartment or a
ah,
flat.
ah.
So it is not possible that you say that this apartment is not going to receive the water.
Receive. Ah, ah. Yeah,
Okay,
got it.
it is
Yeah.
going to receive. Yeah, you can attach a wall here or something like that,
Ah,
and
ah.
that is the secondary option.
Okay.
So broadcast domain is one here. Logically, they all are belong to same
Ah,
broadcast domain.
same but yes.
Okay, because they
Okay.
can receive each other's broadcast, and
Yes.
also the collision domain is one because all of them are connected like that. The data can be collide with each other.
Ah,
Then we have ring topology. After bus topology, IBM
ah,
developed ring topology. IBM is kind of a vendor who try to create things in the start of the networks of
ah,
their own. Like I told you about the AppDic, the codes.
ah.
If you remember yesterday, I told you the ASCII codes and the AppDic.
Okay. Yes, sir.
Yeah.
Yes.
So
Mm.
IBM developed their own codes,
Ah,
even IBM try to create their own monopoly. They create their own hardware, their
ah,
own operating system,
ah,
their own applications,
ah,
everything. They say that if two users are connected through IBM, they are
ah,
going to use our methodology.
ah,
Well, but
ah,
that is the cause they are not anymore in the
ah,
market as a giant now.
ah.
Although they are,
Yeah.
because I have IBM certifications, so I know what they
Yeah.
are doing on the behind.
Ah,
Okay, let's see ring
yes.
topology.
Yeah.
So what IBM does, they created a topology in which
Um,
they connected PCs in these kind of manner.
ah,
What is the purpose to connect the PCs like this? the full duplex, no collision.
No collision.
This is the
Okay.
sending medium, this is the
Ah,
receiving medium.
receiving medium.
So
Okay.
they separate the sending and receiving medium.
Ah,
That's why it is now full duplex.
full. Okay.
Okay, and the access method is called token ring.
Open rings.
When these users send a data,
Ah,
or and each PC has two different LAN cards.
ah,
One LAN card is for sending, the other one is for
receiving.
receiving. The
Ah,
sending LAN card send a data with a token number attached to that, and
ah,
that is going to this PC. Then
ah,
this PC can receive that data and see if it is not belong to it. It will pass the
oh,
token to the
ah,
other
the
PC. It will
second.
going to pass to this.
Ah,
That's how the token is going to work, like a circular
ah,
railway or circular um, bus kind of thing.
ah, ah, ah.
Okay, like
And
ring roads.
yeah.
So
So
how
that the
ring
data
road
passes through all the PCs.
PCs.
Ah,
So that's
either they
why
want it or not.
exactly. So that
Ah,
is why again it is only broadcast supported.
okay, supported. Yes.
You can't unicast a message.
Ah,
You can't multicast a message.
yes.
Okay. So
Yes.
broadcast domain is still one. But
Ah,
what is the benefit? The collision domain.
ah. Sir,
It's still
here,
difficult to troubleshoot. Yeah.
if the PC that at the top is going to send the data to the second one, then it is
Hmm.
unicast, no?
No, no, no. Because the second one can use the
Ah,
same token to
ah,
send the data to for ahead.
ah,
Okay.
okay.
So it doesn't mean that the token is only uses for this one.
Ah,
Okay. So broadcast is still here. No unicast can
okay.
be happened here.
Ah,
Okay. Now the collision domain is nil.
mail. Yeah.
Difficult to troubleshoot, and obviously the cost,
Yeah.
because now you have to attach two LAN cards
Ah,
and you have to lay out two cables in the
ah,
office.
yes.
So ring topology failed as well.
Ah,
Let's talk about these are again the w- revision of star topology.
yeah.
So how does star topology work? Star topology is the topology which is the topology we are using
Mm,
currently,
mm,
usually in the LAN.
ah,
Okay, in the LAN, bus topology and ring topology are kind of obsolete.
ah,
Star topology is a topology which is currently in the use. So we need to discuss star topology
yes.
in depth.
Mm.
Star topology, in star topology, what is new introduced? A central device.
Central
Okay.
divide. Okay.
Before that, in ring topology, no other device is present. Only PC is
Mm,
connected directly.
ah,
Okay. Now there is
okay.
a central device came.
Ah,
It can be hub or bridge or
bridge
switch.
or
There are
switch.
three central devices.
Ah,
Okay. Uh, the cable can be twisted pair cable or fiber optic cable,
mm,
which can be used to connect. The speed is starting from 10 Mbps. It is 10 Mbps.
mm,
Mbps
yes.
to it's unlimited. Why I am saying unlimited? Because if you have a fiber optic cable,
Ah,
so you are sending the data at the speed of light.
ah,
What you need to do, you just need to create a device which can
ah,
send data at the speed of light
ah, ah.
or which can process data.
Process.
So
Yeah.
there are switches available in the market
Ah,
which supports 200 Gbps data
ah,
transmission per port.
ah,
Even there are switches which supports 800 Gbps.
oh,
Okay, so there is
okay.
no limit.
Ah,
The how fast the data can be processed, it
ah,
can be transmitted
okay.
until you reach the processing speed at the speed of the light.
Ah,
Because fiber optic cable is a glass
ah,
cable which on which data travels at the speed of light.
yes.
Okay,
So
and the
data should
twisted
be.
Yeah,
Converted to light, no?
yeah, converted into light. Okay.
Mm.
And the twisted pair cable is the cable on which the data are transmitted uh,
Mm.
at the speed of electricity.
Uh-huh.
Okay. So, and this is the same cable which I called, um sorry, which we called copper cable, or the network
Okay.
connector we used with
Yes.
8 pair. Okay.
Yeah.
There are multiple twisted pair cables, like shielded twisted pair cables, unshielded,
Yeah.
and there are categories Cat 5, Cat 6, categories in that how much copper is present in the
Yeah.
wire. Okay,
Yes.
let so the speed is not a problem here.
Uh,
Shared medium architecture.
yes.
Now this word is used here within the bus topology, shared medium architecture,
Yeah.
and it makes
Sure.
sense
Yes.
here
Uh,
that this medium, this coaxial cable is
uh,
shared,
layered.
but
Yes.
the shared medium architecture word
Uh,
makes sense here when you have a central device.
uh,
Does it make sense?
ye-
Shared
yes.
medium.
Yeah.
Uh,
Yeah. Yes. Everything is shared through this central device. No?
But medium is medium. What is meant by medium? Medium
Uh,
is a wire.
uh-huh.
Okay. Medium
Okay.
is a
Wire.
wire.
Yes.
Right now we are talking about LAN. LAN
Uh,
is wide network.
wire.
Okay. So medium is wide.
Yes.
So uh, the shared medium architecture makes sense. Now, if we see that there is a central device, every device is
Uh,
connected to that central device.
yes.
No device is connected directly to the other device with the same medium.
Uh-huh.
So, what does shared medium architecture means here? It means that at least the
Uh,
PC and the central device is sharing a medium.
oh.
They are sharing this medium to
Uh,
send or receive data. And
yes.
now this can be half duplex or full duplex.
Uh,
Okay.
okay. Okay, sir.
This can be half duplex or full
Full
duplex.
duplex.
It
Yes.
depends on the configuration. I just saw
Yes.
you, uh, told you.
Yes.
We
Yeah.
just saw that
Yes. Yes.
in the network card configuration.
Ah.
That if we switch to half duplex, then it is
Ah.
going to be half duplex communication with mesh switch.
Ah.
Or means the central device. It can be
Yes.
switch, bridge, or hub. Okay,
Ah.
so in the start topology, we can have a half duplex communication or
Ah.
a full duplex
Full
communication
duplex.
as well.
Yeah.
Not like this, that
Ah.
it is always a full duplex communication, the ring topology,
Ah. Ah. Ah.
because sending and receiving medium are always different.
Oh,
Not like
yes.
this. This is
Ah.
always a half duplex communication only.
Ah.
Here we can have half duplex and full duplex both.
Both.
So if it is half duplex communication, we need Sigma CD.
Ah.
But if it is full duplex, we don't need Sigma CD because there will not be any collision.
Ah.
Okay.
Yes. Yes.
Now we have unicast, multicast, and broadcast support. Means I can send data from PC1 to PC2, and this
Ah.
central device is going to send the data to the PC2 only, not to
Ah.
PC3 or PC4.
Yes.
So
Yes.
it can be unicast or it
Multicast.
can be multicast. I can
Yeah.
send data from PC1 to PC2 to PC3, but not
Ah.
PC4.
Ah.
Okay, and this
Okay.
central device will be responsible. It
Ah.
knows that on this port it is PC2, and
Ah.
on this port it is PC3, and this
Yeah.
port belong to PC4, so it is not going to send data to PC4.
Ah.
So
Yes.
we can have unicast type of communication, we can
Ah.
have multicast type of communication, and we can have broadcast as well.
Broadcast. Yes.
So everything is supported here
Ah.
and easy to troubleshoot.
Yes.
Means if PC1 is complaining that I am
Ah.
not getting the connection, so we are
Ah.
going to troubleshoot only its wire. We are
Ah.
not going to troubleshoot everyone.
Yes.
Broadcast domain. The
Ah.
broadcast domain is still one. Means logically, they
Ah.
all the devices can receive broadcast from each other. Means if PC1 send a broadcast message, the broadcast message is going to transmit it to PC2, PC3 and PC4. So all
yes.
can receive the broadcast messages from each other. So broadcast domain is one. Logically, what was the domain? Logical group of devices. So logically, all the devices in the same group of broadcast.
Yes.
And how we can say collision domain? So collision domain is uh, can be identified as per the central device we use. Each device can have a different collision impact. Okay, so when we discuss about each device, then we are going to know that how this collision impact occurs.
Okay.
Okay, so let's discuss hub first. Hub is the central device which was the first device introduced in the star topology.
Okay.
Okay, so
Yes.
hub is the first device came, and it is the device which is used to create the star topology. So hub is a layer 1 device.
Layer 1 device. Yes.
Okay, layer 1 device means it is kind of internally bus. What they do, they create a box, and in that box, just for the sake of understanding, I am saying that, okay, it's not is this simple, but what they does, they just put a metal plate inside, and what they do, connect everything to that metal plate. So what is going to happen? They are going to behave like a bus topology. So all the properties a hub follows are from the bus topology.
Yes.
So cable is used, trusted pair, speed is 10 Mbps, shared medium architecture, half duplex. A hub can be full duplex because there is just a metal inside.
Yeah.
If it is half duplex, Sigma CD. Need broadcast is supported. You can't unicast. Means PC1 can't unicast a message to PC2 only
Okay.
because inside there is this metal plate. And if PC1 sends something, then PC2, PC3, PC4, everyone is going to receive.
Yes.
Although that PC2 is going to receive and process, but PC3 and PC4 ignores, but still they are receiving. So it is a broadcast. It is not a unicast or multicast. Easy to troubleshoot than hub bus, sorry. Why? Because still we know that if PC1 is getting issue, it's the problem of this wire. So the thing only change is troubleshooting.
Yeah.
Okay. Every other thing is the same as in the bus topology. So broadcast domain is one. Logically, every device can receive the broadcast from every device. The collision domain is one. Logically, every device data can be collide with another device. Okay. Any question here?
No, sir.
Clear?
Okay.
It's
Clear.
all clear. And what about the time? Do you have energy? Means if basically I used to give lectures at least for the 2 hours, so I am well uh, practiced for that. And teaching is kind of thing which makes me energetic. So I can carry on long sessions as well. But obviously there is the absorb stack. So a person who can absorb not a lot of things at the in a single session. So we are going to discuss the bridge, and then I am going to throw a question for you, which is for you have to answer me tomorrow.
Okay, sir.
So what is a bridge, or how does bridge works? So bridge is the layer 2 device.
Okay.
Okay.
So,
And what I meant by layer 2 device,
oh,
that it is an intelligent device which
oh,
forward the frame. Why
frame one
it is written as a frame? Because it is on layer
layer
2.
two. Oh,
Okay. Based on MAC address table. So
oh,
what does bridge do? Bridge create a MAC address table
oh,
of every device connected to its
two.
port.
Oh,
Okay, so bridge knows the MAC address table of this PC or this PC and this PC and this PC.
oh,
The cable is used trusted pair with the bridges. Speed
oh,
is 10 to 100 Mbps because we are not, and they are all obsolete. Okay, bridges are
oh,
also
oh,
obsolete. We will discuss why.
oh,
That's why we don't say that bridge have a 1000 Mbps speed or something like that, because
oh,
they are not right now available.
okay.
Shared medium architecture. Again, the shared medium architecture means that PC1 and the
Oh,
bridge, they
oh,
are sharing this medium.
medium. Yes.
Bridges are were half duplex.
Oh,
Okay,
okay.
so their ports were by default configured as half duplex,
Okay.
and they use in the half duplex mode. That's why
Oh,
Sysma CD.
ah.
But what
In,
is, yeah,
sir, in this bridge network, the PC1 2, they have only one LAN card.
yeah, the one
Oh,
LAN card which is connected to the bridge.
okay. Only the ring network has two LAN card.
Yeah,
Okay.
exactly.
Okay.
Okay. So we can have two LAN cards, but both are connected
Mm.
to the bridge. Not like
Bridge.
that, that one is for sending and one is for receiving. They
Ah,
both can connect to the bridge and have different communication on both the network cards.
ah,
But that's not like that we discussed in the ring topology.
ah,
It is
ah.
different.
Yeah.
Means I can connect my laptop with a wired network and at the
Ah,
same time as the wireless network,
ah,
or I in a PC we can have two LAN cards,
ah.
a built-in LAN card, and we can attach a
Mm.
external LAN card.
Ah,
So and we are going to see multiple LAN cards in a device.
yes.
We have a topic where we are going to see the multiple LAN cards in a single device and how
Mm.
they are working and why we need to use them.
Okay.
So it is a thing which is going to be performed.
Okay.
Okay. So here we come. Unicast, multicast, and broadcast.
Yeah.
So in Bridge, we can send a unicast message.
Ah,
How? Because Bridge knows
with MAC
that
address.
PC1
Ah,
and PC2 and PC3 and PC4, their MAC addresses. So
yeah.
if I uh, attach my MAC address that I am PC1 and
Ah,
attach the MAC address of PC2 that this data is going to send to PC2, means
ah,
source address is PC1, source
ah.
MAC, and the destination MAC is PC3. So
Yes.
if it knows that PC3 is connected on this port, then it is
Ah,
going to send the data on this port only, not
yes.
to PC2 and or PC4.
PC4. Yes.
So unicast is
Ah,
possible,
possible.
multicast is possible, and
Ah,
broadcast is also possible. So all
mm,
the three modes of communication are supported.
okay.
Okay,
Mm.
fairly easy troubleshooting.
Ah,
Broadcast domain is one because
one.
everyone can receive the broadcast. The
Ah,
collision domain is number of ports.
ah,
What does that mean? It means because it is a half duplex communication
ah,
between bridge and PC. So here can be the collision occur. Here collision can be occurred.
ah,
So PC1 and bridge,
ah,
they may, and this port of the bridge make a
ah,
collision domain, a group
yes.
where collision can be occurred.
Yeah.
Similarly, PC2 and this port.
Ah, ah,
Similarly, PC3 and this port. Yeah,
yes.
it is not going to happen that if PC1 send the data and PC2 send the data at the same
Ah,
time, it is never going to collide.
ah,
Because when the data received, it is going to process. and it is processed by one. Even it is received at the very exact same time, but it is going to be processed one by one. Okay,
Yes.
so
Yeah.
PC1 data and PC2 data cannot be collide. But
Okay.
if PC1 sends some data and at the same time bridge sends some data to PC1, then
Yeah.
this can be collide.
Collided. Yes.
So this is a collision group, means this is a collision domain. So
Okay.
there, how many domains are in this topology?
4.
4. So every port is a different collision domain.
Okay.
So there are 4 collision domains in
Yeah.
this topology. Okay, and this
Okay.
diagram shows how a bridge works.
Okay.
So how a bridge works, that uh, for example, yeah, how a MAC table works. Okay, not
Yeah.
a bridge, the MAC table in the bridge. So
Yeah.
by default, the bridge doesn't know about the MAC addresses.
Okay.
Its MAC table is empty.
Uh,
Means if I attach a bridge and then I attach PCs, the bridge doesn't know that which port is connected with which PC.
Okay.
Okay, how it is going to know when a PC starts sending data?
Uh,
Okay, for
okay.
example, PC1
Uh,
send a data, and with that data PC1 attach that my source MAC address is PC1, and I am going to send the data to the destination MAC, which is PC3.
3.
Okay, so what is going to happen on the back end? That the bridge receive this message and learn from this message the source MAC address of PC1 and write it in the MAC table, that on my
Okay.
port number 1,
Uh,
the user who is connected has a MAC address PC1.
PC1.
Okay,
Yes. Okay.
but obviously it doesn't know anything else, means this PC3 is not in his table for now. I
Okay.
said that table is empty.
Uh,
Even in the start, he doesn't know, in the start, bridge doesn't know about the PC1.
okay.
How does it know?
When it gets connected or
When
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 it.
it's received a data, some data.
Uh,
And in that data, the PC write its source MAC address.
uh,
Okay, so the source MAC address is the mechanism from which bridge learn about the MAC address.
uh,
Okay,
okay. Okay.
this makes sense.
Yes, sir.
Now, the
Uh,
data received also mentioned destination MAC,
uh,
that this data is going to be destined for PC3.
PC3.
But when the bridge looks in this table,
Uh,
there is no PC3.
yeah.
What is going to do? It's
Uh,
going to broadcast. Okay?
okay.
What it's going to do? It's going to broadcast. So what it will do, that it broadcast all the data on all the ports.
Okay.
Okay,
To all the other
all
ports
the
other
other
than
ports
PC1.
other than PC1, because it received it from PC1. So it will make the copy of the data, multiple copies, and send the copies to everyone. Now PC2 is going to receive that data and see that it is for PC3, so it is going to ignore. PC4 receive and it
Yes.
sees that it is for PC3, so it is going to ignore. But when PC3 receive, so
Right response.
it says that, wow, it is for me. I am interested for this. Someone is interested to talk to me. Okay, someone is interested to talk to me, so I should reply.
Yeah.
So when PC3 is going to reply the PC1, because we discussed it, that every time the network communication happens, it's two-way.
Yes.
If a data is sent, there is
Ah.
something to be received.
Ah.
Okay. So when it is
Okay.
going to reply, it is
Ah.
going to write its source MAC address
Ah.
and the destination MAC address PC1 because it received the message from PC1.
PC1. Ah.
Now, when this information comes to bridge,
Ah.
what it does, it learns this PC3 from the source MAC address field.
Ah. Ah.
Okay, and it
Mm.
write in its MAC address table that on my port number 3,
Ah.
there is a PC resides whose MAC address is PC3.
PC3. Yes.
Okay,
Okay, sir.
and that's how its table gets update
Ah.
whenever it received a data on each port.
Oh, yes.
And this time, when this
Ah.
reply is happening, response is happening, it is
Ah.
going to be unicast
Ah. Yes.
because the destination MAC address PC1 is
Ah.
now in the MAC address table.
Ah.
So the first time message is sent, it is broadcast because
Ah.
don't uh, uh, remember it as a first time. Okay, just
Ah.
remember it like that. Whenever
Ah.
a bridge
Ah.
doesn't know about MAC address in its table,
Ah.
what it does, it broadcasts the data.
Ah. Whenever
Okay,
it doesn't. Sir,
yeah, whenever
if
it
it
doesn't
is
knows about the destination MAC.
okay. So
Okay,
it once it is happening, so it is is it in the memory that this is the port number?
yeah,
It is saved.
exactly. It is saved in the memory MAC address table.
Ah, okay.
Because bridge is the layer 2 device, it is an
Ah.
intelligent device, it has a
Ah.
processor and it has a memory.
Memory.
So it can store things, it can
Ah.
process things.
Ah, okay.
So it can learn the MAC address and memorize it and use the processor to forward to specific ports,
Ah.
data to these specific ports. It is an
Okay.
intelligent device, it is a layer 2
Ah.
device.
Ah.
It can perform actions which are meant to be performed and which are instructed to be performed. It can
Ah.
follow the instructions.
Okay. It's like a
Processor.
computer.
Exactly. It's like a
Not
computer.
like the hub and other topology.
Yeah, exactly.
Okay.
Okay. So
Yes.
it is an upgraded version
Okay.
of device which is used in the network.
This
Now we have the last
um,
device which is switch. Yeah.
these are all in LAN, no? Or in wired
Yeah,
LAN.
yeah. No, no, no. In
Okay.
LAN.
In
Uh,
LAN.
basically, uh, as I told you, the
Ah,
difference between LAN and WAN.
yeah.
What was
ISP
the
is
difference? A service
a
provider.
service provider.
It is possible that a
Ah,
service provider use bridges for
ah.
its communication,
Without the wireless for wireless communication.
wired or wireless communication.
Same mechanism, but without the wires.
No, no, no. With wire or wireless both.
Both. Ah.
Yeah, bridge is a wired device. It's not a wireless device.
Oh,
There are wireless bridges,
ah.
okay,
Yes.
but we are talking about the wired bridge.
Yes.
Okay, so
Okay.
there are wireless bridges as well,
Ah.
but we are not talking about wireless right now. We are talking
Okay.
about wired devices only.
Okay.
And wired devices only in the context of LAN network only.
Okay.
So right now our focus is LAN network
Ah.
and on this LAN network devices which can be
Um,
connected through wire.
yes.
Okay,
Okay,
it's
sir.
clear. Now
Yes.
we have another device, the last device, which is known as switch.
Switch.
Um, Switch is a central device,
Ah.
layer 2 device.
Layer 2
It is
device.
an intelligent device. It or frame forward as MAC table.
Ah.
Cable can be twisted pair of fiber optic.
Yes.
Speed can be whatever the
Ah.
fiber optic supports.
Ah.
Shared medium architecture, it can be half duplex and full
Ah.
duplex.
Duplex.
Okay.
Ah.
Access method is Sysma CD. It
Ah.
can support unicast, multicast, and broadcast.
Broadcast.
Easy to
Yeah.
troubleshoot. Broadcast domain 1,
Ah.
collision domain number of ports.
Ports.
The same thing I
Ah.
copied from above. That
Ah.
source MAC address is learned like that, and
Ah.
destination MAC address is then broadcast for if it doesn't know in the table,
Ah.
and if it knows then it is unicast, and
Yes.
that's how its MAC address table updated. Means everything I wrote here about
About the bridge.
everything
Ah. Same.
exactly approx only the cable and the speed are changed. Okay.
Ah. Yeah.
And because why the speed is changed? Because the cable is supported by fiber optic.
Fiber optics.
Okay.
Yeah. Ah.
Everything is similar.
Ah.
Okay.
Yeah. Yeah.
But
Ah.
I said that bridges are obsolete.
Yeah. Ah.
No one is using bridges
Ah.
nowadays. Everyone is using switches.
Switch. Yes.
Okay. Means
Okay.
switches toppled the bridge market.
Ah.
Although the basic functionalities we discuss of the bridge
Ah.
are exactly the same as how switch work.
Ah.
So what is the catch here? Oh, oh, notepad. This, eh, 1 minute.
Ah.
If I know the shortcut, why I'm going through this? Okay, so difference between bridge and switch in one word. This is your assignment for tomorrow. I told you that I am going to give you a question
Yes.
for tomorrow.
Okay.
So you can search, you can ask ChatGPT,
Yeah.
whatever you want to do.
Ah.
I need a one word answer. It is
One word.
important.
Okay.
Okay.
Difference
Whatever I
between.
told you about the bridge and the switch,
Okay.
okay, I
Yeah.
need a one word answer that what is the main difference between bridge and switch?
Okay.
Because we saw that everything is similar.
Yeah.
The basic functionality of bridge and the basic functionality of switch
Which.
is same.
Ah.
Then what comes which changes the destiny of the bridge, and
Okay.
they are obsolete,
Ah.
and switches are in the market.
Okay.
Okay,
Okay.
so let's
Is
wrap
it
it up here. Any
is it
questions
about
from? Yeah?
full duplex and half duplex one? Is it
No,
that?
no, no. I full duplexes are two words. Half duplex are two words.
Ah.
Okay, I'm
Oh, only one
strictly
word.
I'm
Ah.
strictly that word is not written,
Ah.
and that word is not discussed.
Oh.
Okay, that's
Okay.
why it's assignment, na? Because it's something which we
Ah.
doesn't know right now.
Ah. Ah.
So
Okay.
you have to explore it yourself. That
Okay.
what is that one word which is the difference between bridge and switch.
Okay.
Okay, so
Okay.
let's wrap it up.
Yes, sir.
And today we have discussed a lot of things.
Yes.
We uh, wrap the OSI model,
Yeah. Yes, I know.
which was continued from our previous session.
Yeah.
Why does the shortcut not working? Yeah. Okay. So we summarize the OSI model first, and we see that this summary is crucial.
Ah.
At least for this part, the layer
Yeah.
4, layer 3, and layer 2.
Ah.
Okay.
Yes.
Then we discuss the encapsulation.
Yeah.
Encapsulation is nothing but just a
Ah.
wrapper each layer
Yeah.
attached with the data.
Data. Yes.
And with encapsulation, there is decapsulation.
Encapsulation.
Then we discuss the difference between OSI and TCP.
Okay. Yeah.
And we assure that OSI model is the model we need to remember,
Ah.
and which is the norm of the industry whenever a discussion happen. So it is a reference model.
Ah.
So everyone whenever referring layers, they must be referring the OSI model layers,
Yes.
not the TCP/IP model layers. Okay, then
Okay.
they discuss the TCP protocol suite, that the protocols which are uh, connected with TCP/IP model
Yes.
in real world they are used.
Okay.
Then we learn some basic definitions. The simplex, half duplex, full duplex, half duplex. Whenever the shared medium architecture is here, and whenever it is half duplex, collision can be happen. Okay, collision can happen. Full
Yes.
duplex, when the medium is not shared and there is no collision in full duplex.
Yes.
Unicast, multicast, broadcast, the
Yes.
casting, the propagation, the propagation of data, unicast is one to one, multicast one to many, broadcast one to all. Domain. Domain is not yet, we have done not yet with the domain. There is something we are going to discuss with the domains tomorrow, because I know that students don't get it fully, the broadcast and collision domain. The things these that we wrote the these numbers and how these numbers change. Then we talk about the LAN network topologies. Topologies, arrangement of devices, the bus topology, obsoleted, ring topology, obsoleted.
Yes.
Then then we have star topology. Then star topology, which is currently the standard in LAN network. Usually in LAN network, the star topology is applied, and we have central devices in the star topology which are used hub, bridge, and switch. The difference between the hub, which is layer 1, the bridge, which is layer 2, and switch is our switch is we discussed that switch is same as the bridge, but there is a single difference, which is we are going to discuss tomorrow.
Okay.
Okay. So any query from this revision, or is these topics?
This is clear, sir.
Okay. So we are going to discuss everything. Continue
Sir,
the.
one thing, the Sysma and CD, could you explain one more? There's little bit confusion there.
Let me clear it one more time.
Yes, sir. Anything.
Sysma CD is always comes into play when there is a half duplex communication. Okay, Sysma CD is connected with half duplex communication. And why it is connected with half duplex communication? Because in half duplex communication we had shared medium. So what happens that when devices know that they are communicating on a half duplex mode, they must use Sysma CD before sending the data. Okay, so what they does, they send a sense bit to sense the carrier. Carrier is the medium. Okay, medium is the carrier.
Whether it is free or not.
Exactly, whether it is free or not. So when this sense bit response is that the medium is free, they are going to send the data. Or why they are sensing? Because there is multiple access of the medium.
Yes.
Okay,
Got
so
it.
and collision detection is performed when if it happens that two devices send the data at the same time.
And it
And
get cancelled so that the sender can know that it is collision happened.
yeah, collision happened, and they are going to send that data again.
Okay,
Okay,
sir.
so this is Sysma CD, which is built-in, means this method is written in every PC. Means my laptop knows this method Sysma CD. So when I switch to the half duplex mode, what my laptop is going to do, or what my device is going to do, my LAN card, it is going to use this method to communicate.
Communicate, sensing. Yes.
Okay, so whenever the half duplex comes, the Sysma CD's role is going to play, and each device When I am calling each device, it
Mm.
means laptop, switch, router, mobile phones, even the Bluetooth devices. They follow Sysma CD if they have the shared medium.
Okay.
Okay,
Okay.
so the Sysma CD is a protocol. It is a protocol. Okay, to and the access method for every device which can communicate using half duplex communication. Means if a device is built and there is no half duplex mode in that device, then that device doesn't need to have the protocol of Sysma CD.
It's not very okay.
Okay.
Okay, sir.
Anything else?
And the shared medium is
Shared medium is
medium means with
the
here the
same
whole
medium used
for
for sending
receiving
and
and
receiving the device
receiving. Okay,
data.
okay. Okay. Okay.
Okay.
Yes, sir.
So try to revise the PDF, and if
Thank you.
there are any questions,
Yeah.
we can take them tomorrow.
Okay, sir. Thank you.
Okay. Bye.
Okay, okay. Okay, thank you very much, sir. Nice class.
Okay. Bye.
Okay. Thank you.
Recording.